Hello, good day. So today's topic is about memory management, allocation strategies under operating system. Memory allocation in operating systems manages main memory by assigning spaces to processes broadly divided into contiguous processes occupy adjacent blocks and non-contiguous paging segmentations methods. Key strategies include fixed dynamic partitioning, first fit, fast one, and best fit, which is smallest fit, and worst fit, largest leftover, and the buddy system for efficient allocations. Key memory allocation techniques: contiguous allocation, processes are loaded into a single contiguous section of memory, and fixed partitioning MFT, memory is divided into fixed size static partitions, easy to use but causes internal fragmentation. Dynamic partitioning MVT, partitions are created dynamically based on process size, reducing wastage but potentially creating external fragmentation. Placement algorithms for placement algorithms for partitioning. First fit allocates the first hole that is big enough, which is fast, and best fit, which is allocates the smallest hole that is big enough, minimizing waste. Worst fit allocates the largest hole and leaving a large leftover, which can be useful. Next fit, similar to first fit, but starts searching from the last allocated block. Non-contiguous allocations or processes are stored in a non-adjacent physical memory, eliminating external fragmentation. Paging memory is divided into fixed-sized pages, logical and frames physical, allowing non-contiguous storage. A segmentation memory is divided into variable sized segments based on user values, example code, stack. Buddy system memory is divided into sizes that are powers of 2, allowing for fast splitting and merging of blocks. Comparison of techniques of fixed partitions, uh, partitioning simple, low overhead, but high internal fragmentation. Dynamic partitioning, more efficient, no internal fragmentation, but high external fragmentation. Paging segmentation eliminates external fragmentation but requires complex mapping. Static allocation, memory is allocated at compile time. Dynamic allocation, memory is uh, allocated at runtime. Example using malloc in C. Partitions allocation methods in memory management. Memory management techniques are methods used by an operating system to allocate, control, and release main memory during program execution. They ensure that multiple processes can use memory efficiently without interfering with efficiently. Memory management techniques are methods used by an operating system to allocate, control, and release main memory during program execution. They ensure that multiple processes can use memory efficiently without interfering with each other. Proper memory management improves system performance and prevents memory wastage. Single contiguous allocation, simplest allocation method used by the MS-DOS. All memory except some reserved for OS is available to a process. Partitioned allocation, memory is divided into different blocks or partitions. Each process is allocated according to the requirement. Page memory management, memory is divided into fixed size units called page frames used in a virtual memory environment. Segmented memory management, memory is divided into different segments. A segment is a logical grouping of the process, data, or code. In this management, located memory doesn't have to be contiguous. Most of the operating system, for example Windows and Linux, use segmentation with paging. A process is divided into segments and individual segments have pages. In partition allocation, when there is more than one partition freely available to accommodate a processor's request, a partition must be selected. To choose a particular partitions, a partition allocation method is needed. A partition allocation method is considered better if it avoids internal fragmentation. There are different placement algorithms: first fit, best fit, worst fit, and next fit. First fit, in the first fit, the partition is allocated, which is the first sufficient block from the top of main memory. It scans memory from the beginning and chooses the first available block that is large enough. Thus, it allocates the first hole that is large enough. So this is how The first fit is allocated, and best fit allocates the process to partition, which is the first smallest sufficient partition among the free available partition. It searches the entire list of holes to find the smallest hole whose size is greater than or equal to the size of the process. So process A is 25 kV. It is trying to find equal or greater than it, which is 25 kV memory. Worst fit allocates the process to the partition, which is the largest sufficient among the freely available partition available in the main memory. It is opposite to the best fit algorithm. It searches the entire list of holes to find the largest hole and allocate it to the process. Uh, you can see it is allocating the huge amount of memory, 60 kb approximately, which is 35 kb is going waste. Next fit is similar to the first fit, but it will search for the first sufficient partition from the last allocation point. Is best fit really best? Although best fit memory minimizes wastage space, it consumes a lot of processor time for searching the block, which is close to the record size. Also, best fit may perform poorer than the other algorithms in some case. For example, CWH6. Comparison of partition allocation methods. So, fixed partition. Advantages are simple, easy to use, no complex algorithms needed. Disadvantages: memory wastage, inefficient use of memory resources. Dynamic partitioning, flexible, more efficient partitions allocated as required. And disadvantage requires complex algorithms for memory allocation. Best fit allocation minimizes the memory waste, allocates a smallest suitable partition as advantage, and disadvantages are more computational overhead to find smallest split. Worst fit allocation ensures larger processes have sufficient memory as an advantage and may result in substantial memory wastage as a disadvantage. First fit allocation, quick, efficient, less computational work as an advantage, and disadvantage here is risk of memory fragmentation. Thank you.